viewers to another episode on ACE your G12 exams. So in this episode we are looking at section B of the 2021 internal science paper 2. So you notice that section B carries 45 marks out of 85 marks. So this is a very important section that you cannot afford to mess up. So find time to revise on section B as much as possible. Go through all the papers covering the last 5 years. If you can do that, you are safe. Let us look at question B1. The following diagram shows the changes of state in the 3 states of matter. Question A. Describe the arrangement of particles in Roman numeral 1 solid, Roman numeral 2 liquid. So basically what is key here is we are required to describe the arrangement of particles. So particles in solids are tightly packed. Okay, so they are ideally tightly packed and they are arranged in a regular pattern. So when they are tightly packed, then arranged in a regular pattern. This is the arrangement. So they are tightly packed and also arranged in a regular pattern. So there is a pattern that they are arranged. Because of that, so these are the key things that you find in the solid particles. So in terms of arrangement, they are arranged in a particular pattern. That's the arrangement. Just trying to explain to you how the arrangement in a regular pattern comes about. So I've given you 3 things. They are tightly packed, arranged in a regular pattern, and because of that they vibrate at a fixed position. So your answer just ends somewhere here. This is basically an extension to help you understand. Then in liquid, so in liquid basically particles are loosely packed instead of tightly packed. Particles are loosely packed. Okay, and they have freedom to move about, and they can move from one point to another. So in terms of arrangement, they are loosely packed. Because they are loosely packed, hence they have the freedom to move about and they can move from one point to another. So basically this is how you answer this question. So in case there was an extension which required you to describe the arrangement of particles in gases, so in gases particles are very far apart. So because they are very far apart, they are able to take the shape of any container, so they are free to occupy any shape. Question B. State the name of the change of states labeled A and B. So A and B. So if you notice, I'll start with A. A, we are changing from liquid to gas. If you look at the arrow, so that should be basically evaporation. Then B is from liquid to solid. So liquid to solid, meaning basically there is freezing. So this is basically freezing. Then C, which is solid to gas, direct from solid to gas without passing through liquid state. This is basically sublimation. So now what is A? Evaporation. What is B? Freezing. So if you go here, we know that A is evaporation, B is freezing. Roman numeral 2 of B reads, which change of state, A or B, is an exothermic process? Explain your answer. So we have evaporation and the freezing. So basically, for us to answer this question, we need to understand what an exothermic process is. So when we're talking about exothermic process, we're talking about basically a reaction that releases heat. So exothermic releases heat. It gives out heat energy. Then the other aspect is endothermic. So in endothermic reaction, basically the heat energy is absorbed. So there is a process of taking in heat energy. So now if you look at these two processes, what you discover is basically for evaporation to take place, you need to have an intake of heat energy such that the liquid start boiling. When the liquid start boiling, it will start evaporating, changing from liquid state to gaseous state. So this one is basically endothermic. Then freezing. So for freezing to take place, basically the heat energy need to be given out such that the energy in the final product, which is the solid, will be lower than the heat energy which was there at the beginning of the reaction. So this one basically is exothermic. So in this case, B is the correct answer. The explanation is basically as water start freezing. So as water start freezing, it loses heat energy to the surrounding. Remember, to the surrounding, hence it is an exothermic process. This is how you answer this question. Let us look at question B2. The following is a list of methods used to separate mixtures: filtration, chromatography, crystallization, distillation, fractional distillation, then evaporation. Choose from the list above the suitable method that would be used to A. Obtain pure water from sodium chloride solution. So in this case, we are obtaining pure water. So since we are only getting pure water, in this case, we just go with a simple distillation. So in this case, the method would be distillation, which is the same as simple distillation. So in this case, what happens is we heat the solution. In this case, then our water is going to evaporate. Then we condense it. The chloride solution, sodium chloride solution, will remain behind. Once the water evaporates, we condense it, and that water, the vapor turns to water, which is known as the pure water. Question B. Separate a mixture of ethanol and water. So here we are getting ethanol and water. These two liquids have got different boiling points. So because they're a mixture, to separate them, we need to use fractional distillation, which is based on the varying boiling points of a mixture of liquids. So in this case, you see fractional distillation. Remember, what is key is two liquids should be a mixture, and this should have varying boiling points to use fractional distillation. C. Obtain copper 2 sulfate crystals from saturated copper sulfate solution. So in this case, the clue is crystals. So during crystallization, what you notice here, the solvent is partially evaporated. Then it will leave a small amount of solution in which crystals will form. So in this case, you notice that this is what is going to be done, which is basically crystallization method. Then D. Obtain barium sulfate from a mixture of barium sulfate and sodium nitrate. So what you notice in this case, barium sulfate is one of insoluble salts. So you notice that though basically all sulfates are soluble, barium sulfate, also calcium sulfate and lead sulfate, these are insoluble salts. Take note of the three: barium sulfate, calcium sulfate and lead sulfate. These three are insoluble salts. So because it's an insoluble salt, it's easier to separate it from the solution of these two. So what you do is basically we just filter. So we use filtration because it's not a mixture of liquid. One is insoluble. Then E. Separate colored substances in a sample of soft drink. So in this case, we are separating color. So when you're dealing with anything to do with color, is basically a chromatography. Let us look at question B3. The following table shows the structures of four particles P, Q, R, and T. Question A. Which particle is a neutral atom? So a neutral atom is that atom that has got the same number of electrons and protons, because remember, protons are positively charged, then electrons are negatively charged. So if you look at the table, you notice that P has 11 protons and 11 electrons. Then Q has 11 protons and 11 electrons. So these are neutral charged. So though it's saying a particle, which particle? So there are two answers here. It could be either P or Q. So n of these will still be correct. Then we look at B. Which particle is negative ion? So a negative ion, basically we're talking about a particle whose charge is overall charge is negative. So negative, it means it has more electrons than protons. So if you look at R and T, T has more electrons than protons, so T is negatively charged. So the answer in this case is T. We have a positive 8, then a minus 10. We are going to end up with minus 2. So the charge is basically, you light the magnitude, which is 2, then the charge follows. So it's basically 2 negative. So 2 negatives is the charge. We look at C. Which two particles are isotopes? So we need to understand what is an isotope. So basically, when we're talking about an isotope, basically we're talking about an atom that has the same number of protons and electrons but different number of neutrons. That's what we call an isotope. So what you notice here in this case, P and Q, they have the same number of protons and electrons but different number of neutrons. So P and Q are basically isotopes. So P and Q, they are isotopes. So why? Because they have the same atomic number, which is basically the number of protons, but different mass number, or a different number of neutrons. D. Use the periodic table to identify particle R. So we need to use the periodic table to identify particle R. So when you go to the periodic table, so you notice that R has 12 protons. So 12 protons, you check which is the same as the atomic number. When you go to the periodic table, the element with 12 atomic number, which is the number of protons, is basically magnesium. So R should be basically magnesium. So R is magnesium. Let us look at question B4. Ethyl ethanoate can be prepared from ethanol and ethanoic acid. Question A. Write the chemical equation for the reaction. So basically we just need to understand the general reaction that happen when basically carboxylic acid reacts with an alcohol. So in this case we have ethanoic acid. We react it with basically ethanol. We are going to end up with basically a reversible reaction, which will give us basically ethanoate plus water. So if we are to write the structures of these, we have basically this, which is basically the ethanoic acid, just helping you to make sure that you understand what is going on, so that if you come across this question in an exam, you don't miss it. So this is reacted with ethanol, which is basically CC, then H, then we have H, then H down here, then we have basically the hydroxyl. So now what is going to happen in this case is basically this and this H, they are going basically to form water. So they are going to form water in such a way that this reversible reaction, the results will be as follows. So that and that combines to give us basically H, this part, and basically this part. So we are going to have C, then this double, then H, then H, then this one here, then we are going to have now this one comes here. We are going to have now, we reverse this process, so we're going to have basically C, then we have H, then H, then we have H down here, then H down here, then we have another H. Then this and that will give us plus C the water. So this is what we are going to get. So ideally, what you notice in this case, we are going to have this is nothing but basically C, H3, then the carboxylic, then this one is nothing but basically it has C2, then H5, then like this. Then this is what is going to give us that. Now this one need to be in the form that we've been given. So this form, which is basically a CH3, then C, then 2, then we have basically C2H5. So let us go back, plus then water. So let us go back and write now the equation, now that we've understood what is going on. So now the equation becomes a CH3, then this, then plus basically we have C, then we have H, so C2H5, then we have this, which is, then this is going to give us a reversible reaction under proper conditions. So this is ethanoate, which is CH3, then CO2, then C this, then plus water, which is liquid. So basically this is how the equation will be. So once we get that, we can counter check to ensure that this is basically correct and balanced. So what you notice in this case, we have 3 oxygen to the left, then we also have 3 oxygen to the left. Then in terms of carbons, we have 1, 2, which is 4, plus 2, which is 4, 2 plus 2, which is 4. Then this side we have 2 plus 2, which is also 4. Then in terms of H, we have 4 plus 6, which is 10. Then also this side we have 3 plus 5, which is 8, plus 2, which is 10. So it's already balanced. So this is how you answer this question. You go to B. Calculate the theoretical yield of ethanoate, which can be obtained from 23 grams of ethanol. So basically the mole ratio is 1, 1, 1, 1. So we are looking for this. So if you use one more here or here, we get one more this side. So we are using which one? We are using ethanol. So ethanol is this one. So what you need to find is, we just need to know the number of moles that are in 23 grams of ethanol. So we know the formula for ethanol, so we just need to find a relative molecular mass of ethanol. So what we notice in this case, we start with how many carbons are in ethanol. There are 2, so it's 2 times C, then plus how many hydrogens are in ethanol. So we have basically 5 plus 1, which is 6, so we have 6H, then plus a carbon, we've already, there are 2, then oxygen is basically 1. So it's just, then we go to the periodic table and check for these numbers. We know that basically hydrogen is the mass number is 1, then carbon is 12, then oxygen is 16. So we can remember those, then we can find this. So we have basically 2 times 12 plus 6 times 1, then plus oxygen, which is 16. When we add this, we are going to have 24 plus 6 plus 16. We end up with basically 46. So 46 is basically the molecular mass. Once we do that, basically we can find now the number of moles, which is step 2. So in step 2, so the number of moles is equal to a mass given divided by relative molecular mass. So mass given is 23 from here, then divide by relative molecular mass, which is 46. We are going to end up with basically 0.5 moles. So 0.5 moles is what we have. So if here we have 0.5 moles, then we're going to produce 0.5 moles there, because the mole ratio is 1 to 1. So now for us to know the mass that we're going to obtain, we need to know the relative molecular mass of this, because we know the number of moles is 0.5. So what we do is, in this case, basically we find the molecular relative molecular mass of basically ethyl ethanoate, which is CH3, then C, then C2H5. Then what we do is basically this is equal to how many carbons? We have 1, 2, then 4. So we have 4 times carbons, then plus how many hydrogens? We have 1, which is 3, plus 5, which is basically 8. So we have 8 hydrogen. Then how many oxygen? We have 1 times 2, so there are 2 oxygen. Then we start adding the molecular mass of a carbon, or the mass number is basically 12, so it will be 4 times 12, then plus basically 8 times 1, then plus 2 times oxygen, which is basically 16. So then multiplying, we have 4 times 12, which is basically 48, plus 8 plus 32. We sum this, we are going to end up with basically 88 grams. So now 88 grams, we know that basically if we have 0.5 moles here, to find the number of grams produced, it will be basically a mass will be equal to, remember, number of moles times relative molecular mass. Remember, number of moles is given by mass given divided by relative molecular mass. So to find this mass, we just cross multiply, hence that's where this formula is coming from. So therefore a mass will be equal to 0.5. Remember, from what we've done here already, we have calculated that these 23 grams, how many moles? 0.5 moles. So if you use 0.5 moles here, we need to produce 0.5 moles because of the mole ratio of 1 to 1. So similarly now, we need to find the mass of this 0.5 moles. Hence, that's where we are multiplying here. Then multiply by this relative molecular mass, which is 88. When we multiply that, we are going to end up with 44 grams. So 44 grams is what is going to be produced. So here the answer in this case, this is 44 grams. Then after answering this, we can proceed to look at the next question, which is question C. If 33 grams of ethyl ethanoate is produced, calculate the percentage yield. So basically the question is asking us to find the percentage yield. So percentage yield is basically given by, so I'll call percentage yield to be PY is equal to basically actual divided by basically theoretical multiplied by 100%. So what's the actual? The actual is 33. Then what is basically theoretical? Remember, the 44 if calculated there was theoretical. So 44 here is theoretical. So then is 44 into 33. So 44 into 33, then multiply by 100%. Then we use our calculator and simplify that. We are going to end up with 75%. We look at D. To which homologous series does ethyl ethanoate belong? So these are basically esters. We feel basically the general formula then we have C, then M, then 2m plus 1. So this is basically the homologous group. So basically, just to emphasize, esters are basically organic compounds that are formed when we react basically carboxylic acid with alcohols. So make sure to understand how this works. Let us look at question B5. The pH scale is used to indicate how acidic or alkaline a solution is. Some numbers from the pH scale are given in the following list. Question A. What type of solution would have a pH of 1? So basically, we are looking at the pH scale, which is basically the potential hydrogen. So pH is basically the potential hydrogen. So the lower the potential hydrogen in a solution, the more acidic that solution is. The higher the potential hydrogen is in the solution, which is a pH, the more basicity the solution is. So if you look at the pH value of 1, this would tell us this is basically an acidic solution. So the solution should be acidic solution. So remember, when you go this basicity as we approach 14, then as we approach 1, this is basically acidity. That's basically what you need to know. Let us look at question B. Which pH value from the above list would be for basically lime water? So again, you need to understand what lime water is. So lime water, basically this is calcium hydroxide. So calcium hydroxide, this is basically a strong base, which is given by this formula. So because it's a strong base, this one should have a pH value of around 14 from here, which is this 14. Pure water. So pure water is basically a neutral. It is basically exactly between acidity and the basicity. So it's neither a base nor an acid. So it should be between. So remember, the potential hydrogen scale ranges from 1 all the way to 14. And the middle value is a 7. So it's between 7 and 8. So we have 7 as basically the answer for pure water. Vinegar. So vinegar is basically, this is an acid, but it's a weak acid. So what you notice, if you look at the values that we have, the one that would mean vinegar would be basically a 3, because 1 is a strong acid. Question C. What would be the color of a solution with pH value of 14 when tested with the universal indicator? So the pH value of 14, we are using the universal indicator. So the pH value of 14, this would indicate a strong base. So a strong base has a pH value close to 14. So this would be basically the strong base. So now if you're using the universal indicator, what we need to know is basically from 0 to 2, this would be red. Then 3 to 4, this would be orange. Then 5 to 6, this would be yellow. So these are acidity. Then 7, exactly, this would be give us green. Then when we have basically between 8 and 11, this is a weak base, which is blue. Then we are going to have, of course, 12 to 14. These are strong bases, and this would be basically violet. So what you notice in this case, 14 is falling in the violet region. So the pH value of 14 would have the color of a violet. So make sure that you take note of those ranges and revise as much as possible. Let us look at question B6. Some reactions of metals V, W, X, and Y are given in the following table. So we have the metal, reaction with water, then reaction with dilute hydrochloric acid. So if you look at V react with water to produce a few bubbles, form slowly in a cold water. Then react vigorously, giving a gas off when reacted with hydrochloric acid. Then W vigorous reaction, a gas is given when reacted with water, then explosive reaction with hydrochloric acid. Then X, no reaction, and no reaction, doesn't react with water, no hydrochloric acid. Then Y does not react with cold water. What metal reacts with steam, then stirred fizzing. Question M. Arrange these metals in order of decreasing reactivity. So we need to start with the most reactive, then end up with the least reactive. So what you notice in this case, W react with water and produces a gas, and also react explosively with hydrochloric acid. So this is the most reactive, and this would be the first one, and this is suspected to be a group 1 element, because group 1 basically they react with water, and these are the most reactive metals. Then followed by, this should be basically V, which react with cold water to produce bubbles slowly, and also react vigorously with hydrochloric acid to produce a gas. So this would be basically number 2, and this would ideally belong to group 2 element. So group 2 element, they generally react with cold water, except for the case of beryllium, which only react with steam. Then X does not react with water or hydrochloric acid, so meaning X is less reactive than hydrogen, not replace hydrogen in the solution. Then we have Y does not react with cold water, but the water metals does react with the steam, and also react with hydrochloric acid. So this should be basically number 3, then this will be number 4. So when you start arranging this one, we notice that W would be the most reactive, followed by V, then followed by Y, then we end with basically X. So this is the order that you arrange these metals. We go to B. Which of these metals could be magnesium? So magnesium belongs to group 2 on the periodic table, so we know that magnesium would be basically V, which react with hydrochloric acid vigorously, displacing hydrogen, which will be produced as the gas, and it will also react slowly with water, which is specifically cold water. Which element would be copper? So if you look at copper is basically less reactive than hydrogen. So what you notice in this case, the element that would be copper is one which will not place hydrogen both in water or hydrochloric acid. So X would be basically copper. So this would be copper. Question C. The equation for the reaction of W with cold water is given below. So we have 2W, then react with water, produces this hydroxide, then plus the gas Z. So in water we have, this is water. So for us to produce this Z, this Z is the hydrogen which has been displaced. So this is basically hydrogen gas. Then this W is the element that is replacing hydrogen, so it should be more reactive than hydrogen. So describe the test for gas Z. So gas Z is hydrogen. So hydrogen basically produce a pop sound when lit. So when lit, hydrogen would produce the pop sound. So this gas itself is hydrogen. Then Roman numeral 2 of C, to which group of the periodic table does metal W belong to? So if you see here, we have already identified the one which react vigorous with cold water. These should be basically group 1 element. And the other way that you can tell, you notice that the hydroxyl has one negative cation. So because of this bond, you notice that the bond is basically W as basically a positive one, then this hydroxyl as a one negative. When we close the valence, we notice that this is a group 1. So this is also the other way you can tell. So this one is basically group 1 from the chemical formula. Let us look at question B7. The following diagrams show two forms of carbon, P and Q. Question A, name the allotrope labeled Roman numeral 1 P. So if you look at P, what you're going to identify is basically we have this carbon forming a covalent bond with 4 others. So the 4 others are 1, 2, 3, 4. Similarly, when you come to the next stage, we have this one, then we have 1, 2, 3, 4. Similarly here, 1, 2, 3, 4. So when such bonds are occurring, then this is known as a diamond. So a diamond allotrope forms covalent bonds with 4 other carbons, as I have demonstrated. So this is the best way to know. So P basically is diamond. Then when you look at a Q, this is basically a graphite. So in graphite, each carbon atom forms covalent bonds to no more than 3 others. So what you notice in this case, what you have, if you have this one is forming a covalent bond with this one, and this one. Then similarly, if you look at the other one, which is this one, will form with also 3. So the maximum is 3. Because of that, this will give rings of 6 atoms. So what you notice here in this case, you have 1, 2, 3, 4, 5, 6. This is a ring. 1, 2, 3, 4, 5, 6. That's a ring. So once you see such the ring of 6 atoms, that is a graphite allotrope. So graphite. So because of this, the rings forms flat sheets that normally lies on top of each other. As you notice here in this case, these flat sheet, then this one. So these one are lying on top of each other. So this is how basically you identify the two allotropes of carbon. We look at question B. Explain the meaning of the term allotropes. So allotropes are basically, these are solid forms of an element with different molecular structure. So basically what we are saying, allotropes are solid forms of an element with different molecular structures. So like you see here, we are talking about diamond and graphite. These are all carbons existing in solid form but with different structures. That's what an allotrope means. So the key term is they are solid forms of an element with different molecular structure. That's what is key. We look at what type of bonding is represented by these forms of carbons. So all of them, they are made of covalent bonding. So covalent bonds. So make sure to understand three types of bonds that exist, which are basically covalent bonding, ionic bonding, and metallic bonding. So make sure to revise those clearly. We look at D, Roman numeral 1, which allotrope named in A as physical property which is typical of metals. So metals are basically they conduct electricity. So the one that has the typical property of metals is basically graphite, which is able to conduct electricity. So this is because, why does it conduct electricity? Because it has free mobile electrons. So these free mobile electrons are the ones that allow it to conduct electricity. So state the physical property. So the physical property is basically it conduct electricity like main or most metals. Let us look at question B8. The structures shown are members of one of the homologous series in organic chemistry. Question A. Give the general formula for this homologous series. So if you look at R, S, and T, they have something which is common. And what is common in this case is basically the hydroxyl functional group. So we have this hydroxyl functional group. So because of that, these are basically alcohols. So these are alcohols. Remember, basically alkenes. Just to remind you, they have got a double carbon bond. Then carboxylic acids, they have basically this double bond of between carbon and oxygen. Then they have also this hydroxyl. So this is basically they are functional group. So having identified it to be the alcohols, then the general formula is basically CN, then the alkane general formula, which is basically 2N plus 2. Now this 2, you remove 1, subtract 1, so now this one becomes now 1, then the hydroxyl. So basically this is the general formula. Then B, what is the functional group for the homologous series? So the functional group is basically, we've already talked about, is basically this hydroxyl group. Question C. S is used as a fuel because it burns in oxygen. Write a balanced chemical equation for this reaction. So we are burning this fuel in oxygen. Then we are required to write a balanced chemical equation. So what you notice in this case, we have this formula is C2H5, then the hydroxyl. So this is basically ethanol. So when we burn ethanol in basically oxygen, which is a gas, then this is aqueous or liquid, then we are going to end up with basically a carbon dioxide, then plus basically water as the products. Now the question requires us to do a balanced chemical equation. So basically what we notice here in this case, this side we have 2 carbon, this side we have 1, so we need to introduce 2 so that we have 2 2. Then the carbons are balanced. Oxygen we've got basically 4 plus 1, which is 5. This side we've got oxygen basically 3. So to balance this one, we might need to introduce another one, but first of all let us try to balance the H. So H we have basically 6 to the left hand side, so we need to have also 6 to the right hand side. So introduce a 3 here, then we have 6 hydrogen, but we have this side we have 7 oxygen. So for last, to balance, what we need to do is we introduce a 3 here, then we have also 7 oxygen. So in that case we've balanced in the chemical equation. Let us look at question D. Which of the compounds R, S or T would have the highest boiling point? So basically when you're dealing with organic compounds, larger molecules tend to have a higher boiling point because of so many bonds that are holding that large molecule together. So basically in this case, the largest molecule in this case is T. So T would have the highest boiling point. So the boiling point increases as the size of the molecule increases. So R would have the lowest boiling point, then T would have the highest boiling point. So basically this is how you answer this question to get the 5 marks.